Hello everyone, today we're going to learn about how to calculate empirical formulas from percent composition. There are 4 steps to this process and there's a little rhyme to help us remember it. Those steps are percent to mass, mass to moles, divide by smallest, multiply until whole. So percent to mass, we convert the percent composition to mass values. Mass to moles, we use the periodic table of the elements and the molar mass to convert between grams and moles. Divide by smallest. Of all of the moles that we calculated, we identify the smallest number and we divide each of the numbers by that smallest number. And then multiply into whole. Sometimes when you divide by your smallest numbers, your answers are whole numbers. If they are not, you need to multiply each of them by a common factor until they all become whole numbers. If you'd come out of your divide by smallest step and you get something that's really close to a whole number, you are allowed to round, but only by 0.15. So if I got 0.88, that's close enough to 1, it's less than 0.15 away, that I would be able to round 0.88 to 1, a whole number. But if I got out of my divide by smallest step 1.17, that's too far away from 1 to round. That would mean that I would have to do my multiply until whole step in order to get the empirical formula. So this doesn't really make a whole lot of sense until you look at an example. So in our first example, a compound is made of 88.9% oxygen and 11.1% hydrogen. What is the formula? The trick when doing the percent to mass step is to always assume that you have 100 grams total. So if I have 100 grams total, 88.9% of 100 grams is 88.9 grams. And 11.1% of 100 is 11.1 grams. Since we're assuming that we have 100 grams total, we can just take our percentages and write them as grams. Mass to moles, we need to go to our reference tables. Oxygen has a molar mass of 16. Hydrogen has a molar mass of 1.008. So I'm going to set up some railroad tracks, usually off to the side. I've got 88.9 grams of oxygen. 1 mole of oxygen is 16 grams, right? That's what that 16 from the periodic table means, that 1 mole of that oxygen has a mass of 16 grams. I write my ratio flipped over so that grams will cancel, and when I plug that into my calculator, I get 5.56 moles of oxygen, so I'm going to go ahead and write that in my table. I have 11.1 grams of hydrogen, and 1 mole of hydrogen has a mass of 1.008 grams, according to the periodic table. Write my ratio flipped over so that grams will cancel, and I get 11.0 moles of hydrogen out of my calculator. It is very important that you include the elements that you're working with in each set of railroad tracks in the units so that you know which belongs to which element. Because as soon as you get outside of this table where everything is organized, it's easy to get confused looking at your own work. The smaller number out of our number of moles is 5.56, so I'm going to divide each of those numbers by 5.56. And 5.56 divided by 5.56 is, of course, 1. There should always be 1 in your divide by row. If there is not a 1, then you have made a mistake somewhere. When I divide 11.0 by 5.56, I get 1.978, which is definitely close enough to 2 that we can go ahead and round it to 2. We don't have to multiply because our answers came out as whole. So this would be traditionally written as H2O, our final answer for the empirical formula. We take the symbol for hydrogen. This is now our coefficient. We take the symbol for oxygen, and of course all of our 1s are invisible in our formulas. Looking at another example, compound is made of 22.33% oxygen and 77.7% iron. What is the formula? So I'm going to go ahead and transfer my percentages down as masses because we're assuming we have 100 grams total and 77.7% of 100 is 77.7. and the same with the oxygens. Then I can get ready to do my railroad tracks. Go to my periodic table. Oxygen is still 16. Iron is 55.85 grams for every 1 mole of iron. So I'm going to set up my railroad tracks. 22.33 grams of oxygen, 16 grams of oxygen, and a mole of oxygen. Grams will cancel out of my calculator. I got 1.396 moles of oxygen. I'm working with 77.7 grams of iron. The periodic table said that 1 mole of iron had a mass of 55.85 grams. Grams will cancel. And my calculator said I had 1.39 moles of iron. So I'm going to go ahead and transfer those numbers to the table, 1.39 and 1.396. 1.39 is slightly larger, so I'm going to divide by 1.39. There's my 1, and my calculator said that this was also 1.00. So I have whole numbers out of my divide by step. I do not have to multiply because I got whole numbers already. So the formula here would be iron, an invisible 1, oxygen, an invisible 1. Our final answer here would just be FeO. Last example. Compound is made of 57.54% carbon, 3.45% hydrogen, and 39.01% fluorine. What is the formula? I went ahead and transferred those percentages down as masses in grams because our total here is 100 grams. I can go ahead and get started on my mole calculations. I'm going to go to the periodic table. Carbon has a mass of 12.01. Hydrogen has a mass of 1.008. And fluorine has a mass of 19. So I'm going to take my 57.54 grams of carbon. 1 mole of carbon is 12.01 grams. Grams will cancel. And my calculator says 4.79 moles of carbon. I have 3.45 grams of hydrogen. The periodic table says that 1 mole of hydrogen has a mass of 1.008 grams. Oh, grams will cancel, so I'm done. My calculator says 3.42 moles of hydrogen. And my last one, fluorine, 39.01 grams of fluorine. The periodic table says that 1 mole of fluorine has a mass of 19 grams. So I am going to cancel out grams, put it into my calculator. It says 2.053 moles of fluorine. I've done all my conversions. I can transfer back to the table. 4.79 moles of carbon, 3.42 moles of hydrogen, and 2.053 moles of fluorine. So of these numbers of moles, 2.053 is the smallest. So I'm going to be dividing by 2.053, which means this is going to be 1. This is going to be 1.67, and this is going to be 2.33. These are not able to be rounded to a whole number. They are very far away from the nearest whole number. But if you notice, 0.33 is 1/3, and 0.66666, or 0.67, is 2/3. So I'm going to start my guess and check multiplication factor with a 3 to undo the third. And when I do multiply by 3 here, I get 6.99, which would round to 7. I get 5.01, which would round to 5, and I get 3, right? Because I took my 2.33 multiplied by 3, 1.67 times 3, and 1 times 3. These are my whole numbers, so I'm all set. I'm going to write my formula for my final answer. I've got C for carbon, and there's a 7 behind it. I've got H for hydrogen, there's a 5 behind that. And I have F for fluorine, there is a 3 behind that. So my final answer is C7H5F3, because I had to multiply by a 3 factor in order to get my ratios to come out as whole numbers. So that's how you calculate the empirical formula of a material from the percent composition. You convert the percent to mass by assuming that there is a total of 100 grams to the sample. You convert mass to moles using the periodic table and the molar mass off of the periodic table. You then divide by the smallest number of moles. You divide each number of moles by the smallest number. And if that does not give you whole answers, then you need to multiply until you get those whole answers. And please do make sure that when you are multiplying, you're multiplying all of your results by a common factor, right? In this case, I used 3. Thank you very much and have a nice day.